Hey folks, welcome back to my thing. My thing where I am trying to write a program to extract the necessary data off the final screen in NES Tetris. And I like to start off each of my videos with a nice, relaxing game. Although this time I'm actually playing a little longer than I usually do. But the goal is to get better. I can really only be efficient on level 15 and no higher than level 15. Most competitions, whoops, start at level 18. There we go. Well, we didn't want to see me play Tetris all day. Okay. And this is the screen we want to extract. Okay, and we'll kick that out there. So let me go to my, where did I, yeah, here we go. So I don't know if I showed this last time, but I got my high score last week, 392,480, so I was really proud of myself. Yes, so we're making a program to recognize all the digits. We're going to extract the line count, the score, the level we reached, and each of the individual piece counts, and so we can aggregate this data and shove it into a database somewhere. And last time we sort of did a proof of concept where we were drawing boxes around each of the digits and then seeing if we could distinguish between the digits just simply based on the number of black pixels that occurred. And it seems like more or less we can do it. It looks like the number of black pixels between the 3 and the 4 is like 0.5%, and so that might be a little tricky, but whatever. It was just a proof of concept. We're going to actually start laying out the basic pieces of our program. And so let's open up Visual Studio and see what we have. Whoops. Every video I drop my controller on the ground, so that's fun. That's fun and exciting. Let's bring this over here. The Tetris Data Extractor. Okay, everything keeps going to the wrong monitor. Here we go. So if you recall, not now Microsoft, if you recall last time we did this little program where we had each of the digits, and then we simply just counted the black pixels and threw them in a list, sorted them so we could see the differences between the numbers. And so these are the numbers from last time. These should be familiar. So today we are actually going to start laying out the pieces of the program. So because Visual Studio lets you have multiple projects and each project is somewhat isolated from the other ones, although they can reference each other, the way it works is each project gets compiled to one single DLL file. And so it's okay if we have multiple projects, that's fine, but only one of them is going to be the main starting point for our program. And already I've noticed I've spelled recognition wrong in digit recognition. That's okay. This project is just a test project. The real project is Tetris Data Extractor. And the first video in this series, we created this model which says this is the important information that I want to extract from this picture. So if we do this, there we go. Score level lines, and then all the piece types and the amount of the number of that type of piece that I got during that game. Okay, and we had initially tried Tesseract, but I think that's gone. I've totally eliminated all of the Tesseract stuff from this project. So we'll set this as a startup project. This is doing nothing right now because we haven't told it to do anything. Okay, so the first thing I want to do is I want to have a class. So let's add a new folder here. And this class is going to be called digit recognition. Same name as the project above. That's just a coincidence. My whole goal is to just delete this digit recognition project. I'm going to try and throw as much as I can in a single project so that I can create a NuGet package so I can use it in other programs that I'm considering. Okay, so we have digit recognition, and we are going to start this off with we're going to make a new interface to describe what we're trying to do. So we are going to call this iDigit reader. Okay. And an interface is really just a way of describing something. And so we are going to say public. Now I could make it a string. I think what I'll do is just make it a string get digit, and then I will give it a bitmap image here, which we saw in the first video. So this is simply, here's a picture, get me a digit. Okay, this is probably going to complain. We don't need to specify that it's public. Okay, so that's my iDigit reader, and that's what I'm going to use. We'll actually make an instance of this. Whoops. This is my class, digit reader. Okay. Yes, of course. And let's extend the iDigit reader. And Visual Studio will give us our getDigit. Okay, so we're going to give this class a bitmap of what might be a single digit. Not 2, not 3, just 1. And we are going to spit out the string representation of a digit. So we want to say, given this image, give me a 4 or give me a 5. I could return an integer, but I want to concatenate these things. So I want to look at each one individually in like a series of 5 digits and say, oh, that's a 5, that's a 4, that's a 3. And then I want to shove them all together. It's easier to do that with strings. So we'll just concatenate them and then turn it into an integer at the end. Otherwise, I got to go, okay, get the integer 5, remember to multiply it by 10,000, and then get the integer. That's just it's headache that we don't really need to deal with. So I'm going to take the methods in our test project. So here we go. We've got a method that asks if a pixel is black. We've got a method that asks what is the percentage of black. I'm just going to copy these, bring it over into digit reader. These are private variables, and now I can use them here. My bitmap is here, and I am going to go back to my program. And yeah, it's really just, so var percentage, I'm going to call it fingerprint because that's what we've been sort of calling it lately. It's a fingerprint of the bitmap. So get percentage of black bitmap. Okay, this will give us our unique fingerprint. And now we got to figure out, okay, how can I recognize this? I should probably run this again and save the output just so we have this saved. What just happened? I just wanted to copy that. Okay. All right. Now we need some type of a data structure to be able to figure out, you know, we're going to get an answer. We're for sure going to get an answer to one of these. We're going to get a number back, and we're going to have to determine which number it is. Now, I'm not sure that I actually want to say, hey, these, you know, it's precisely this value. Because if it's not, you know, if there's 1 pixel off, for whatever reason, we're going to get a totally different value. I probably want a range. But yeah, I don't know. And the idea here is that we want to come up with a way that works and then iterate over it in time to make it better and make it more streamlined and make it more foolproof, because I think we're going to need, well, we're definitely going to need to do something special with the 6s and the 9s to distinguish them because they're the same. And, you know, I think the 4s and the 3s might run into an issue. So I'm going to say I have 10 digits. And I possibly am going to have 10 different ways of deciding if it's a digit or not. So for my first pass, my first idea is I'm going to do this. I'm going to write this massive switch statement. And then I'm going to write my different cases. So case, no, you know what? This isn't a switch statement. This is an if statement. We're going to say if, and I'm just going to do is 10, and we're going to write this fingerprint bitmap. So what I'm doing is I'm going to make a method return 10 is 0, return 0. That's it. And this squiggly line is like, what is that? Well, that's a method, and this is going to determine if a digit is 0 or not. And I'm going to say return fingerprint equals, now we're going to make this into a dictionary. So we're going to say private dictionary, and a dictionary is just something that holds a key value pair. So we give it a key and we give it a value. So this becomes 8. And my formatting's really screwed up because it doesn't like the equal signs at all. So we're just going to do this, this. So a dictionary is we're gonna be able to say, hey, what's the decimal fingerprint for the digit 6? And we're gonna be able to quickly get at it. But first I have to turn this terrible list into a dictionary. So bear with me. This will all look pretty at the end, I promise. This is just setting up the dictionary. Normally you wouldn't set up a dictionary manually, but we have so few values. You know, if it was really big, you'd read it from a file or something. I have to give this a name. Let's call this fingerprints. There we go. What's the problem here? Representative of the best of it. Oh, okay, fine. We'll make it a double. Okay. Now. Oh, come on. What's the oh, right. Okay. Ay, ay, ay. I thought it was going to format it nicely for me. Okay. And it says I can make it read-only. Read-only just means once I instantiate this, once the dictionary is created, you can't change it in any way. That's a little misleading. You can change the values in the dictionary. You just can't reassign it to a brand new dictionary. So it's not as foolproof as the term read-only specifies, but seems to specify anyway. I think there's something called a read-only dictionary. You can do that. Whereas this is not a read-only dictionary. This is a read-only dictionary. Awesome. And you know what? I think I just want to pull this out and put it down at the bottom because I don't ever want to see it again. Okay, so now I can say return fingerprint equals fingerprints, and now in curly brackets I can say, look, is this 0? And this is a decimal. Sure, we'll call it a double. Sure, we'll call this a double. Doubles are have a lot more decimals than decimals. Man, that's confusing if you don't know what you're talking about. The numbers after the decimal point. A double type number has more of them than a decimal type number. Okay, so there we go. Now, why did I include bitmap? Like Visual Studio saying, look, you can remove this. Oh, I can? Okay. Why is the only... What if I actually want to do it and not suppress it? Oh my word. Whatever, doesn't matter. I want it. I could take it out because I'm not using it here, but I might use it, and that's kind of what I want to keep it. And I'll tell you why I might want to use it. Because if we find out, just bear with me. 1, 2, 3, oops, 4, 5, 6, 7, 8, 9. There we go. 8, 9. Perfect. Then I want to return, whoops, 1, 2, 3. Yeah, software development is about naming things and changing your mind. That's what you do all the time. So already I realized, you know what, it's really dumb to bring in the bitmap. If for sure I don't need to bring in the bitmap. If I need to do it later, whatever. I'll do it later. Okay, is it 1? Is it 2? And we're just going to make Visual Studio make these for me. There is clearly a nicer way of doing this. And the goal is to one day it will look as nice as it should. Already I see that no, I don't. For 2 I don't need. For 3 I don't need. The only one I for sure need the and I shouldn't have made all of these. Oh goodness me. I think I can just oh, bear with me, folks. I've done a really stupid thing. That's okay. See, I want the bitmap in for 6 and 9 because we're not able to figure that out based on the fingerprint. So the 8 will get rid of the bitmap. The 7 will get rid of the bitmap. 6 needs it. 5, we don't need it. 4, we don't need it. 3, we don't need it. Okay, now that I wasted all of our times, here we go. And then, if we get to the end, we're going to throw an exception saying I couldn't verify what the digit was based on the fingerprint. And we're going to interpolate this string. So this will just say, hey, you know, figure out which digit it is. And if I get to this line 27 here, and it says I haven't figured it out yet, something's gone wrong. Let's just throw an exception and pick up the pieces manually in this first pass. Okay, so now we're going to go through all of these fingerprint. How do we know if it's a 1? We're going to return whether the fingerprint is equal to the fingerprints of 1. And I could have said, look, if it's not any of the other numbers other than 6 or 9, if it's not 6 or 9, then just directly address the dictionary. But I can't talk while I'm typing this monotonous typing here. But I think I'm going to have to, in the future, customize each one of these slightly. And then it becomes, you know, ultimately what we should do is I should be copying this. See, again, I don't make very good decisions when I'm talking. See, I should just do this. Why can't I do this? Boom. Change that to 5. I think ultimately the ideal thing to do, oh, this is 6. Let's not, is to get a probability that something is a 1, the probability that something is a 2, and so on and so forth. And then pick the one that has the highest probability. This we're just going to say if we determine it's a 0, we're not even going to try any of the others. So in a real life application, this is probably not what you want, but I suspect this is going to be okay for our purposes, and we may need to change this up a bit. But if we do need to change this up, look, this is just the digit reader class. We can change this to our heart's content later on. Okay, so here we have all of our numbers, and I think what's the problem here? Oh yeah, is 6. So I think what we're going to do is chop the 6 and the 9 in half with a horizontal line. So we'll take the top half and the bottom half, and then get those two the percentage of black for those two. And for a 6, there'll be more black on the top half than the bottom half. And for the 9, it'll be vice versa. And I think that's how we're going to distinguish them. So I might have to change up my get percentage of black pixels here. Change that decimal to an F. Okay. So for the 9, let's start with the 9. So if fingerprint equals the fingerprints for 9, which is the same, so we're going to say if it's not equal, return false. So we kick out of this if it's not got 9's fingerprint. It still could be a 6. So we're going to take the bitmap. Hopefully I can chop this. Get bounds. What does that mean? Gets the bounds. I want to take let me just see if I can do something with the Bitmap Constructor. So I can make a new image from an image. I can scale an image, make a new image. I can scale the image. It's not looking good. Huh. Well, I might have to let's add to my percentage of black. The problem is this method that gets me the percentage of black pixels only takes this entire image. So what I'm going to do is I'm going to say, look, I can give you an entire image, or I can give you vertical and horizontal bounds. So I'm going to say int width, and this will be a nullable. So what this means is I can either provide it or not. So int width equals null, and int this is looking a bit more complicated. Okay, so just one second, I'm going to do a Google search. Let's see if we can't find the answers to our problems. Let me go C#, bitmap, create bitmap, crop original, crop a bitmap image. And here's Stack Overflow, the greatest. Whoa. A bitmap factory. What is this? Looks like you can make a rectangle. I don't think that's what I want. Oh my word, no. You know what? Let's make a brand new one. We'll make a brand new get percentage of black pixel. And this will give me a bitmap. It'll give me a starting image. It will give me a width that I want, a height that I want. We're going to say an X offset and a Y offset. And this will let me define a rectangle of the pixels that I want to iterate over. So in the same way, I'm going to say int total pixels equals, this time it's width times height. I'm specifying it directly. Int black pixels equals 0. And now instead of starting at 0, I'm going to start at my X offset. And I'm going to go until X is less than width. X plus, whoa. Calm down there, X plus plus. And I'm going to start at my Y offset here. Where Y is less than the height. And we're going to go Y plus plus. And we're going to copy this this logic. If it's black, I have to get pixel XY. Then we are going to increase the number of black pixels. And then we're going to return black pixels times 100. And divided by total pixels. And that will give me a way. Perfect. This has the same name as this, but that's okay because it has a different parameter list. The compiler knows. So if it's not equal to the 9's fingerprint, return false right away. Then we're going to say var top half equals get percentage of black. And now I can do this one or this one. This is the one I want, bitmap. And now my width, it's always been 45 by 40, I think, are these pictures, but I want to, or 45 by 39. I want to keep it as generic as possible because I want the image to be able to be different sizes. So I want to use relative sizes and not absolute sizes. So I'm going to say the width of the rectangle I want to crop is the image, or the bitmap. I've called it bitmap in this method. Width divided by 2. The height is the bitmap height divided by 2. The X offset is 0 and the Y offset is 0. So this will give me my top half. And the bottom half, let's just call this top. Again, naming things. See, the half was superfluous if I have a top and bottom. Like, what does the What information does the half get me? The word half. Okay, and now this time we'll do the same thing with the same size rectangle. Come on. Oh my word, I'm typing all things wrong today. Look at that. Width. This time my offset though is my, so this is my where's my IntelliSense? I think this is my X offset. So it's still 0. That's fine. Because I'm still starting at the left, but I want to start halfway down this time. And so this is a bitmap height divided by 2. Okay. What's the problem? Does not exist. Get percentage. That's how you spell percentage. Okay, so that's, so if it was a 40 by 40, this would be get me a rectangle that's, see, I made a mistake. The width is always the same width as the original picture. It's the height that's just halved. And then the Y offset is the height divided by 2. Yeah, so that's right. Okay. Yes. And then I'm going to say if top is greater than bottom, that means there's more black pixels in the top, then it's going to be a 6. So I'm going to say return top is less than bottom. So this will evaluate to true or false. Is top less than the bottom? And remember, less means the number of black pixels. If there's less black pixels in the top, meaning there's more black pixels in the bottom, then I think it's a 9. Because I think there's more black pixels on the bottom than the top of a 9. And this is going to be exactly the same for the 6, only reversed. Where's my 6? There we go. We can change this to 6 just for, even though 6 and 9 are the same number. Okay, that's good. Whew. Let me just make sure my recording is being awesome. I'm so nervous recording. Now that this is my first video I've done in a little while that isn't being streamed, because I was having some issues with Twitch. And I tried YouTube Live, and the quality wasn't as nice as I'd hoped. So for now, I'm just recording these. When I get super rich and famous, then we'll go back to streaming. Okay, that's good. We have our digit recognition. Now, the next thing to do would be to write tests for all this, which we're going to do. So let's write some tests. The idea here is that so a unit test, and we're gonna do this. Let's see, I have about 20 minutes left. Yeah, I think we can do this. So unit tests typically live in a different project than your main test. So here we go. We're going to, I can do this. We're going to add a new project. And this is a console app. That's fine. And this will be called Tetris Data Extractor Tests. And I'll put a dot here just because that plays nicely with the namespaces. So this will create a new project called Tetris Data Extractor Tests, and the whole purpose of this project will be to test the classes in the Tetris Data Extractor. A few things we got to do for these things. So we have to install some testing specific NuGet packages, and that's always exciting. So you have to decide which test runner you want to use. I always use NUnit just because it's what I'm most familiar with. So let's install this. And it's going to give me NUnit 3.1.2. Okay, I accept. I also want the test adapter. Whew. Yes, I accept that as well. And yeah, we might as well install that too. I'm not sure if that's right on. So in C# there's two very typical test runners suites, NUnit and XUnit, and they have the same basic idea, but we don't. It doesn't really matter which you use. There's pros and cons to both of them. The main pro to NUnit is it's the one I learned first and I'm most comfortable with. So, and that reminds me, before I forget, let's go to our Tetris Data Extractor. Go into Properties. And no, go to here. Can I do that? Net standard. Is that gonna? Oh, 2.1. Whoops. Here we go. Now that Tetris Data Extractor doesn't have any entry point into the program, it's just a library. It'll just be a DLL which we can use. It won't actually be a, hey, start up this program. We don't need it to be a .NET Core project. Excuse me, we can make it a .NET standard, and if you don't know what that is, don't worry about it. It's not that big a deal. Your unit tests have to be .NET Core, however, or else they won't run. Everything will compile, they just won't run. How fun is that? Because .NET Standard doesn't run on a runtime. It doesn't have a runtime associated with it, but .NET Core does. But .NET Standard libraries can be used in .NET Core, .NET Framework. You can use it in Xamarin and Mono and all those sorts of wonderful things. Okay. Anyway, if that all didn't make any sense, don't worry about it. Here we go. Recognition. So typically this folder structure is going to look the same as it's going to mirror the Tetris Data Extractor project. This will be called, what did I call this? Digit reader. Okay, digit reader tests. Okay, boom, here we go. We have digit reader tests. This is a test fixture. This is how NUnit defines a test. Let's just make sure everything's working. Let's say testing. So we create a method, one method per test, and we say return true, or no, we don't return anything. We say t equals true. That's it. But the thing is, now I can go over here to Test Explorer. This should get picked up. Oh, it doesn't get picked up because I didn't annotate it with the word test. Now that I have, it should get picked up. Look at that right there. It's got a blue exclamation mark because it has not been run yet. So let's run this test. Oh. What's going on? Tetris data extractor tests. What? This is unfortunate. Why does my unit program does not contain a static main method suitable for an entry point? I'll have to figure that out. Unit test projects don't need... My hour's almost up. So what I'm going to do, the problem is unit tests don't need an entry point. It's complaining that it doesn't have an entry point. So I'm just going to make an entry point and tell it to just deal with it. So here we'll go. We'll say, whoops, almost spilled my coffee. Static void main string args. Done. Okay, whatever. I'll have to figure that out. Why isn't this running? Arg folks, why isn't this running? Did I forget to include a NuGet package? Maybe I need to install the test adapter. Now, can I run this? Holy crow. Okay, you know what? We're going to delete this. Boom. Because I know you can write a unit. Bear with me 1 second, folks. This is going to be a little bit hacky. Problem is, I tried to do something like I do at work all the time, and my work setup is just ever so slightly different than this setup. So we're going to try and create this again, although this time we won't make a console. We'll make an actual test. And this will be called Tetris data extractor.tests. Trying again. Yeah, and this isn't really... So it's given me all these tests. I don't want to use the test, the built-in. So I'm going to install NUnit, install the test adapter, which will install, oh, that doesn't actually install NUnit. Okay, let's install this. Wow, that installs a lot. I should also say I don't have a lot of experience working in .NET Core 3.1, so it is what it is. Okay. This becomes a test fixture because we're using NUnit. This becomes a test because we're using NUnit. We can kill that. And now this should run. What is going on? What's happening to my life? Everything succeeded. Hey, there we go. Okay, so this green check mark means everything works. Now this isn't a test that did anything. It's not even a test that's in the right folder. We're just going to kill it. So I'm just curious what this added. Maybe I just didn't have the test SDK installed before. Okay, anyway, now we're down to like 8 minutes. So let's see if we can't write some quick unit tests for this. Digit recognition. Recognition. This time I will spell it correctly. I'm going to add digit reader tests. Okay, this is now a test fixture. This is a public class. And we're just going to do this. It's okay because I'm going to make a new instance of my digit reader. And I use the word SUT. That means system under test. That's what we're testing. We're going to create this method that NUnit is going to look at this setup annotation and say, oh, we're going to run this method before every single test. So if there's 4 tests in this class, this setup method will get run before each one of them. And it'll be okay. New digit reader. Some people don't like to use setup methods. They've always served me well. It seems like it's going to be okay. Okay, so what I need to do inside this digit recognition, I'm going to add a new folder, and this will be called test images. Okay, we're going to bring over all the digits that we copied over last time. So all of these, we're going to add them to our test images here, and I'm going to select all of them and tell them to get copied to the output directory if newer. Okay, so these are available for us to use. So this test will be called, what did I call my method? Get digit. Okay, here we go. Public void get digit should recognize 0. And that's it. A void method doesn't take any, doesn't produce any parameters. The way the unit test works, if it gets through the method without throwing an exception, it considers it done. And I'm going to actually install another package. You really don't have to do this. C# gives you some built-in assert methods, but again, I like to use fluent assertions. It just makes it a little bit more English-like. Because you can say assert equals, and then in parentheses, you know, this equals this. Or you can just say this should be this. That's what fluent assertions gives you. So we have our system under test. It's our digit reader. We're going to And actually what we're going to do, should recognize, I'm just going to say should recognize. This is even better. We're going to write a test case, and this will be test images slash 0.bmp. This test case annotation is going to run this method multiple times, and it's going to bring in a file name for me, so it'll run it for each test case. So the first time, file name will be this. Then it'll run it again, and file name will be this. And then file name will be this. And you sort of get the idea. 3, 4, 5, 6, 7, 8, 9. Because we really only have one test to do. Give it the image and see if our digit reader correctly recognizes it. But we can't just give it a file name. We need to know what it's supposed to be. So this is supposed to return the value 0. This returns 1. This is supposed to return 2. And I'm going to copy this. Oh yes, copy and pasting is also a software developer's life. Okay, 3, 4, 5, 6, 7, 8. And we're really close to the hour, and so I'm hoping this works. So we now have another parameter here, expected. This is an expected digit, and we've made it a string because we're going to concatenate them eventually. Okay, so now we're going to get the image, and we're going to new bitmap, and this will be file name. Okay, and then we're going to be we're going to get the digit equals the system under test. We're going to get digit for the image. And then we're going to say digit dot should be expected digit. So this will throw an exception when this image, any image in the list where this is not going to give us this, and this should pass. This will run 10 separate tests. We'll see them in the Test Explorer. Maybe we can already see them. Yes, there's 10 tests. There we are. Here we go. So we're going to run them, and we're going to hopefully see what we see. So let me just run them all here. And we'll see which digits have a problem. All of them have a problem. Well, I suspect something else is happening. What's the problem? Parameter is not valid. Huh. Okay, so this is where we start. This is where we start debugging. So I'll put a breakpoint here. It failed on every single one of them. Something is not working here. So I will, instead of run it, I will debug this test. It will run and it will hit this breakpoint. Now, what's my file name? Test images, expected digit is 0. So, what's my problem here? Parameter is not valid. Okay, I wonder if my folder structure is not quite like I think it is. Let's have a look. In the tests bin debug folder, this is where it's running from. Oh, I should have digit recognition test images. Huh. Digit recognition / test images. Okay, let's stop this. Okay, let's debug this again. Okay, so now we're okay. So the file name is 0. The expected digit is 0. Let's do this. Uh-oh. I couldn't verify what the digit was based on the fingerprint 69.6467. What is the get percentage of black? So it grabbed a fingerprint that it didn't grab before. Whereas before the 0 was 63.6467. Oh, but you know what? It's because I made everything. Oh, crap. Okay, that's okay. Because of the decimal double nonsense. So what I'm going to do is we'll go in here. Because I made these doubles. Something is strange. Okay, what I'm going to do is I'm going to put a breakpoint here. We're going to debug this. We're over our hour. So unfortunate. We're so close. I'm going to hit my breakpoint here. Now the fingerprint dictionary actually only has up to the 6.4. Because okay, that's fine. And now we're gonna see if it's 0. So the fingerprint is 6467247 and ends in 7734. Fingerprint's 0 Huh. Whoa, guys, what's going on? Did I make my dictionary incorrect? Okay, I'm going to go to the immediate window and go fingerprint of 0. What is fingerprint of 0? Oh, no. Fingerprint of 0 does not exist in the current context. Well, it certainly does. Okay, what I'm going to do is I'm going to stop it. For some reason my immediate's not working, so I'm going to go var t equals fingerprints of 0. This is too bad. Now I'm going to put a breakpoint here. Then I'm going to debug it. Now I'll be able to see exactly what fingerprints of 0 is. My concern is that it's not going to be equal, because it's going to be ever so slightly off. So right now my fingerprint I'm looking for is 63, ends in a 734. The fingerprint I'm getting is 63, ends in 643. 63.646726, 63.64674700. Interesting. Well, what we can do, I'm going to have to stop this. I will concatenate these videos together. But I need to go. I have to do stuff today. So unfortunately, we didn't quite get it down, but wait, 5 seconds and you should see my my attempt to fix this. The problem is the fingerprint that we're calculating is so, we kept so many decimals that we're not getting the same equality, and we really should be. I'm actually surprised that we're not getting the same, but I think what we'll do is we'll just truncate it to like 3 decimal places, and then that should be fine. So, okay, I'll be back.